Oh yeah, it helps if I turn that camera on, doesn't it? Oh, it's cold as hell up here today. JVC. What the heck? Deactivate, activate. How's it going, guys? Yo, yo, yo. Oh, I think OBS has crashed. Well, what can you guys see right now? I think you can just see a frozen screen, hey? Okay, one sec. Wait, you can see everything correctly, right? Let me know what you guys can see, because right now it looks like OBS has crashed a little bit on the visual side, just as I fired it up. We can see you and the chat and the amp. Huh. Oh, it is actually working, but it's not working for me. Look, do you want to see what I can see? This is what I can see. OBS is frozen for me, but it's still streaming okay. Well, as long as it's still streaming okay for you guys, that's all that matters, I guess. Although I can't actually make sure and check what I'm showing is what's correct. this is all I can see. I'm just like frozen on the screen here. Oh, when you try and switch camera, it goes black. Okay, well, bear with me one sec. I'll just quickly restart OBS. Be back in one sec. Okay. Are we back? It's coming back probably in a sec. Give it a minute. It should come back. Oh, wait. Got the scope. Okay. Oh, yep, scope's load up. Oh, yeah, hat cam. Oh, yeah. Oh, that's green. Okay, let's just fix the color of that one. Okay, that's all working. Nice. It's always a bit hit and miss. Hey, it's all working. Woo! Nice. That one. Scope cam, hat cam. Yeah, we're good to go. It's always literally just a hit and miss as to whether the OBS works when I first turn it on or not. How's it going, guys? Happy Sunday. Hope you're well. Hope you've had a good weekend so far. It's probably morning time for most of you guys over in the States and also Canada, and it's probably the afternoon in Italy. Hello from Canada, hello from Florida, Pennsylvania. So just while the stream gets going, I'm just putting the screws back in the powerhouse we fixed yesterday. Just while we get the stream going. 4 PM here, Sweden. You know, I found out something interesting about Sweden yesterday. Apparently, you can't buy leaded flux. Leaded flux. You can't buy leaded solder in Sweden anymore. That sucks. Like, if I had any ideas about moving to Sweden, unfortunately, they would probably be killed off by that, because I can't use lead-free solder. It's horrible. It's absolutely gross stuff. Constant snow in Arizona. Wow. Send us in a picture. Just enjoy. Send us in a picture to either the NSV audio email. Yeah, actually, yeah. So send it to NSV audio email. Let's have a look at what it looks like in Arizona right now. Send us a picture. Exactly. Order from eBay. Oh, that works, does it? Isn't that illegal though? What happens in Sweden if you get caught importing leaded solder? Is it like pretty serious, or is it just like a slap on the wrist, like a, you know, hey, don't do that? 12:23 in Suriname. Sound Doctor, send us a picture from Suriname as well. I'd love to see where you guys are all from, what your current situation is right now. nsvaudio@gmail.com. I'll put a little link in the chat here. nsvaudio@gmail.com. I'm going to put a space before the @ just so that bots don't. It's not so easy for them to copy paste. Love to see what you guys are up to right now. Send us a picture, and we'll have a look. Grand Rapids, Michigan. Grand Rapide. I think is it pronounced? It's not pronounced Rapids, is it? Is it pronounced Rapide or something? Grand Rapide, not Grand Rapids. Done it about 5 to 6 years now. Don't think they bother with even looking. That's fair enough. Yeah, it's probably one of those rules that it's a rule, so that people follow it if they follow the rules, but they're not like that keen on strictly enforcing it for those that don't. Probably one of those. Nice, Justin Joy sent a picture. Let's have a look and see what it's like, what the snow's like. Let's take a peek. Here we go, here's my emails. When I go to the internet, guys, does the stream lag or slow down at all? Just out of interest. Don't know if it does. I don't drop any frames. Arizona snow. Let's have a look. Wow, that is a lot of snow. Heck. Looks awesome. Looks magical, doesn't it? Look, the sky is white. This photo might as well be in black and white. Do you know what I mean? Like, if you desaturated this photo, it would look no different. Sky is white, trees are dark grey, white snow, white ground, grey pole. That is very snow. Wow. We like if we get that in the UK here, we only get it very occasionally, and it only lasts for like a few days. So it's always a bit magical when we get that here in the UK. It's always a bit exciting. It's always like, oh well, yeah, it's snow day, woo! Whereas if you got the snow all the time, all year round, it's probably not that exciting, and it might get a bit annoying actually. But yeah, if you want to show us where you're from on the stream, send us a picture of what it looks like outside right now. Love to see where everyone's from and what the situation is for everyone right now. We always say, damn it, snow again. Yeah. So if you went with this yesterday, this is just an amplifier that we fixed yesterday. Nice and easy. Big board though. Big 15,000 watt amplifier. Lauris, how's it going? Thanks for jumping on the stream. We've been getting weather like this for weeks and weeks. Is that pretty normal though? Is that like standard procedure for where you guys are? Or is it like a bit extreme weather? You know that this is a British stream because pretty much all we're talking about so far is the weather. Right, got a few more screws to put in. Let's try and find out where they go. And on this side, 2 more over here. We usually get snow, but not this much. Jason says, Zigen Widge Day 2, Enix Day, Shranang Mangs here. That's what Jason said. Oh man, David, thanks for the 20. We haven't even done anything yet. Wow, holy crap. Thank you very much, my friend. That's very kind of you. Love the vid, Sam. Don't forget to hit the like button. Yeah, I can do if you like, but I don't really mind if you don't. It's not really something I strive for. Sam Doctor says, Orgi man wij twee alleen. That sounds dodgy. Like that sounds a bit dodgy. Orgy man with twee alleen. I missed the last 2 streams, so glad I didn't miss this one. Thanks for jumping on, Kubaz. Right, let's get these screws in from this side. I spent the entire morning today playing Hogwarts Legacy. That's how I spent my morning. Did you have to change the insulating tape where it burnt through the case? No, no, not at all. It didn't burn through the insulation tape. The black marks you see are literally just soot, just like where it's burnt and there's like ash and soot just got thrown everywhere. But the actual, if you look underneath the MOSFETs here, it's like still fresh, clean. Don't need to change that at all. It's absolutely fine. And it also doesn't need thermal paste. For some reason, factories love putting thermal paste in with SilPad 900. It actually worsens the pad's performance. With SilPad, you shouldn't really use thermal paste because it adds us another layer of substance that the heat's got to get through. The SilPad is designed to be pushed and squished up against non-flat surfaces for transferring heat. It sort of squishes, has like little bubbles on it and stuff that will squish down and fill gaps. If you add thermal paste, it just adds another medium for it to have to get through first. So it's actually not ideal to use SilPad, to use thermal paste with SilPad. But yeah, if anyone else wants to send a picture of where they are, what it looks like outside right now, shoot it in to nsvaudio@gmail.com. We have a picture from Anibal. Nice, let's have a look at this. This is what it's currently like in where did you say it was? St. Petersburg, Florida. Wow, that's a nice blue sky. A couple of cars on the drive. A little bit dry and doesn't look like it's rained in a while. Yeah, nice, man. Looks like a nice day out there. This shit must get annoying, like parking your cars under these trees. It must get like really kind of dusty and like lots of leaves and pollen and stuff on the trees, on the cars, sorry. Lots of pollen this time of year. Yeah, pollen is one of my worst enemies. I do suffer from hay fever, unfortunately. I am a sufferer. Just Enjoy is envious of that. Look, should we go through these last 2 pictures? So far, we've had pictures come through. Let's do this, and then... So yeah, so far, the 2 pictures we've had submitted are this one and not that one. Where don't I go to the this way? Here we go. This one. What's Windows doing? I want to go left from that one. What is with my Photos app? Nope, no idea. But yeah, either way. One extreme to the other. Can't say that the stream isn't worldwide. Charles is from Long Island. Nice. Is it a Long Island though? Or is it just a scam? That's Dutch for that. We are the only two Surinamese here in the chat. Nice. Yeah, it's just going to be a chilled one here today, guys. Just if you're not doing much today, just whack the stream on in the background while you're hanging out. Got a couple of bits I want to look at though. Might change the nozzle on my Ender 5 for Boom or Bust, so we can print the next series. Sorry, the next episode's enclosure with the 0.6mm nozzle instead of the 0.4. If I was in the garage, I would literally be chilling out because it would be cold as hell. Annabelle. What are you up to in the garage? You working on something, or just have a little system in there, just chilling out? Doing some work on a car. I need to do some work on my car soon. The Proton needs some TLC. Sadly, I need to pull the dash out. For fuck's sake. Not looking forward to that one. It's kind of a two-man job as well. Jesse's like, to be honest, I'm getting sunburnt outside the shop today. Wish I was getting sunburnt. If I was getting sunburnt, that would mean it'd be nice weather. I don't wish I was getting sunburnt. I wish that there was the possibility for me to get sunburnt. That didn't feel right. Something about that didn't feel right. No sunburn here, says Charles. Just sent you a view. Let's have a quick look. Oh yeah, got a couple of more emails come through. Wait, what's this? What's this picture of? This is like a 360 image of the sky. Wind chill. Hey Google, what's 25 degrees Fahrenheit in Celsius? Ooh, -3. Sheesh. That's your sky. The screwdriver, yeah, it's good. It's nice. I got the black edition. Someone sent it to me, so it's just really kind gesture, a really kind donation. Someone sent this screwdriver to me. If I was buying one, I probably wouldn't have chosen the black edition, for the same reasons that Linus didn't really want to do a black edition, because it will visibly perish much more than the silver one. So the tips have already started to perish a bit. Like the black's come off the tips already, and I've only used it for 2 days. But it looks awesome. It works functionally beautiful. So yeah, it's really cool. I like it. Makes my life a little bit easier here. A lot of you people are probably thinking, hey, why aren't you using an electric screwdriver? Why aren't you using a cordless one? Well, because in my experience doing this, I need to feel the torque, because these heat sinks are made of the cheesiest aluminium that you will ever come across, and I need to feel when it starts going from righty-tighty to righty-loosey before the inevitable disaster happens. Yeah, the email address is in the chat. Scroll up, Jesse. Scroll up in the chat, the email address is there. What's your opinion on the down for sound amplifiers? Are they okay? Just bought a JP23. I don't know, man. I can only go by what you've seen because we don't have a distributor for them in the UK, so I can't really check. Annabelle says, I own a repair automotive shop. Nice. Last thing I want is to do work on cars when I'm at home. No, that's fair. If you work on cars as your job, you don't want to work on cars when you're at home. And then there's me working on amps when I'm at home, but also when I'm at job. At job is at home job home, something like that. Kobat says, I planned on installing custom tweeter panels today, but it's raining and I don't have a garage, unfortunately. Yeah, no, same. The house that I'm in did have a garage when it was originally built, but the previous owners converted the garage into another room for the house, which I'm actually quite glad for. I like having the extra rooms in the house. But yeah, it does mean we don't have a garage, so can only work on the car when it's nice weather outside. Could a cheap amp be taken apart and juiced up by swapping components? Not really, no. Not really. In order to get any more power out of an amplifier, you need to change pretty much every main component on the board. So at that point, you might as well just buy the amplifier that you need, that has the power that you need. Because it's going to be more effort and cost more money to upgrade a smaller amplifier to do more power. Hey Sam, the corner camera's all blurry. So this camera's all blurry because the scope's not on. So all you're seeing is the screen of my oscilloscope while it's off. So that will show up nicely when the screen comes on. Can an SFB amp components be changed so it can run half ohm? No. No, the Sundown, the full bridge amps, those SFBs, the components in them themselves are great. Like, you can't really get any better than IRFB 4227 or 4115s and stuff like that. Those amps use like really expensive good components. The problem is the rest of the circuit that's controlling and driving those components that is not designed very well, and redesigning that won't help it do 0.5 either. But the fact is, every single 1 ohm stable amp can run at 0.5 given the right circumstances. It's not necessarily down to the amp. So every single time somebody wants to run 0.5, it's always, hey, can this amp run 0.5? Not, does my system allow for safe 0.5 running? That's the question you should be asking. Not, does this amp run 0.5? Can this amp run 0.5? They all will and they all won't, depending on the rest of your setup. If you've got a HCCA in a tiny fourth order, and you're playing like 80 hertz, then no amplifier that's 1 ohm stable is going to survive at 0.5. But if you've got DDZ4s or Digital Design's 9500 series or FI audio subs or something like that, and you've got them in a nice spacious ported box or 6th order or something, or and you're playing low frequencies closer to FS, then yeah, most amplifiers are going to be absolutely fine with it at 0.5. It's not down to the amp, it's down to the use case. Demo says, Sam, I wanted to thank you for one time. You helped me find the problem with my Sound Digital 12K like 2 years ago. Rising this, so I appreciate it. Oh, no worries, man. Really glad you got it up and running. It's very satisfying, and it's great to hear that you got that amp up and running again. Hey Sam, check my other pictures when I'm done with this one. I'll send you pictures of the audio. I'm going to install JL Audio with W7 13.5. Nice. Yeah, cool. Interested to see. Almost there. Just a few more screws to go in this, and we can move on to something cool. So Eddie asks, what would be the best sub setup with the top down? It's difficult because obviously with a convertible, you don't have the cabin loading like you do in other vehicles with a hard top, with or with an actual cabin roof. And a lot of sub setups really depend on the cabin loading to give you the sound that you want and give you the sound that you expect. In a convertible, what I've tended to find is, I don't know how true this is, but I tend to notice that sealed enclosures or sealed chambers tend to have better sound in near field when you are quite close to them. I don't know if that's due to a lack of port noise or whatever it is, but yeah, sealed boxes can sound much nicer when you're right up next to them, or when you're not loading off of something. But I don't think that stands much truth. I think that's just must be coincidence in the experiences I've had in the past. I don't think that actually holds much acoustic truth to it, but that's been my experience. For a convertible, yeah, you just want to. I'd say you want to try and get as much displacement as possible, because you haven't got any sort of cabin Helmholtz to help you out. So I'd say cone area is probably going to be king. You might struggle with getting the sound out of the boot into the listening area, into where you're sitting. A lot of people do ski hatch builds with a convertible, having like a 4th order or 6th order firing through the ski hatch. That can sound all right. Obviously, the problem with the convertible is that the roof's going to fold down into the boot, isn't it? So where do you put a big sound system? I was going to say something directional, like a Paraflex, would be great, or some kind of horn enclosure, but you're not going to really have space for that. So yeah, it is tricky. You know what I do actually in a convertible? I do as much as I could with the boot, maybe like a ski hatch, a blow through, something like that. Get as much actual speakers as you can, as much actual sound out of the boot as you can. Then what I do is I'd run some bass shakers. I'd run some tactile tactile shakers on the front seats, because that will make up for a lot. It can make a really weak sounding system perceive like a much more powerful one. You know, it feels like a much more powerful one just by having bass shakers on the seats. See, in a convertible, that's probably the route that I would go down. Matt K, yeah, it's just on the side. I haven't looked at it since probably I last updated you about it. It's just a side project, and I haven't had time to go back and look at it in a while. Is that the power ups from yesterday? Yeah, I'm just putting the top back on while I wait for the stream to pick up a little bit. It's just a chill Sunday. Just a chill Sunday today. Nothing too crazy. Hopefully. Have you ever worked on a Crescendo amp 2K or DC 2K? Yeah, absolutely. They're very, very generic boards. So I've worked on anything from DC or any of those brands. I have definitely worked on. I have an older amp and want to add the fan. It has it on the board, but I'm not sure if it's worth it. I know probably not really, unless it's overheating to the point where it goes into protection. Probably not really worth it. Hey Sam, is it okay to show pictures on live stream? Yeah, sure. Good morning, 13BTR. I'm good, man. I'm alright. Just chilling on my Sunday. Mike Honda, hope you have a safe drive to Texas, buddy. Stay safe out there on the roads. I'll be listening and talk texting. Well, don't take too much attention away. Talk texting is supposed to be good for driving, but from my experience, it actually takes your attention more away from the road because often it doesn't really get it quite right. It doesn't hear you correctly, or it stops listening or something like that. So just enjoy your drive. You can always catch the stream later. There's probably not going to be too much exciting stuff going on today. I'm just kind of chilling out, hanging out with you guys. Now I'm going to try and keep my desk really tidy this time. He says, infinite wisdom and all that famous last words. So I moved my workshop to a different room. You might notice it looks a little bit different. I want to really try and keep it really tidy now. And I want to try and keep the bench really clear of junk and screws that I don't know what go to. Because that happens, I end up with random screws on the bench and I'm like, hey, where did this screw come from? Alex, what's up? I've been following you for a long time. When you used to play all the bass music on the JBL computer speakers. Oh man, that's a long time ago. Let's get the camera angle that way a little bit. Thanks for supporting me for so long, man. What do you think about two separate isobaric enclosures with 4 6.5s? You don't need to isobaric 6.5. 6.5s already have far too much motor force for their cone area that you don't need to give them any more. If you've got 4 6.5s, best to run them individually, either sealed or ported, whatever you can fit. Maybe even a horn style enclosure for the 6.5s if you can fit it, but I don't know what can fit in the back of that. I've only got about 8" of height. 8" height clearance to work with. Yeah, I wouldn't go for isobaric at all. Not with 6.5s. Isobaric is really good for when you have a bunch of drivers that have pretty weak motor force but large cones, and you want to up the amount of pushing force that the motors have on the cones, or if you have extremely limited space and you want to halve the enclosure volume that you would otherwise need. 6.5s already don't require a very big box and they already have far too much motor force for their cone anyway, so don't go giving them double that. Yeah, I definitely could do with one of those magnetic plates actually. I've seen those for a while now. Oh, hang on a minute. So it looks like we used all of, obviously we've replaced all of the power supply FETs in this, but it looks like Powerus sent over a bunch more than was needed. So thanks Powerus for the free 1404s. Appreciate that. Very kind of you. So we'll put those in the parts box. Okay. Let's have a look. Got some parts over here. Can whack them into. Ah, here we go. Brazil PS FETs. That's a bit. That is full of. What is that full of? Where did they come from? Oh, 1404Zs. I must have bought a bunch of 1404Zs. I've forgotten about that. No worries. Find another empty tray somewhere. Okay, 1404's in there. And then now these ones that came out of the amp, I'm actually going to save these ones that came out of the amplifier, the ones that are good, because the reason that one bank of power supply FETs failed in this amplifier is because the MOSFET shorted to the heatsink through the thermal tape. So all of the other MOSFETs in the other banks should be absolutely fine and actually brand new, because this was a brand new amplifier. So I've got a little box here of salvaged used power supply FETs that have come from similar situations where they've been taken from an amplifier that did fail, but the failure type or the way that the amplifier failed, I know for certain that those power supply FETs weren't stressed in any way, so I can keep them as spares in a pinch or something if I'm repairing something of my own. It's just good to have. I don't want to throw them away because they're absolutely fine. So let's put them in here, get a new tray for these, and we'll obviously throw away the dead ones, but the the ones that didn't get damaged, we'll keep those and put them in something sometime for a project. Okay, cool. So I can put this Paris away now, put this back on the racks, and get something else to look at. Should be kind of interesting what I'm going to look at next, actually. Not something that you'll expect, I don't think. Okay, here we go. This might end up being quite interesting, actually. Also got a bunch of spare 10 ohm gates. That's good as well. Very kind of you, Paris, to send those over. So I have a 12K Paris. Don't think I know the 12K. Maybe it's an older one. I thought it went 10 and 15. Maybe it's an older 12K that was around before I really caught wind of them. How do the FI audio Neo subs stack up to the other Neo subs? Well, there's loads and loads of Neo subs. Like compared to a DDZ, they're obviously not as good, but they're absolutely fine. The thing with the FI Neo subs is the FI Neos don't necessarily have any more motor force than their ferrite counterparts for the same grade of sub. They're just Neo because it weighs less and it's cool. It looks cool. There are some other benefits, but it doesn't automatically mean that it's got mountains more motor force than a ferrite equivalent. One thing I didn't care for on the Paris was the two-piece cases. Yeah, I don't know really. I'm in two minds about it. I think part of me thinks it's kind of cool. You can take the you can get access to front and back of the board without taking it out of the case. But being a two-piece case like that does mean that the case has less thermal mass because it doesn't have the thick aluminium in between the two end pieces. So yeah, in two minds about it. Did you have any luck with the JL amplifier sub-channel inductor? Yes, Chris, fixed that. So if anyone was watching a stream recently, I was working on a JL Audio 5 channel with a dodgy sub-channel inductor, and it was heating up, and we weren't reading enough inductance on the meter. Turns out all I needed to do was just give it more turns. So obviously we weren't able, I am not able to wind it as tightly as it would have been wound in the factory. So the factory inductor had 25 turns on it, and I thought, okay, putting 25 turns back on it, even if they're slightly less perfect, less tight, should be fine. But yeah, we couldn't quite get to the 0.04, I think it was millihenries that we needed. But yeah, I think I ended up putting, I think it was 30 turns, and that brought it to 0.04, which is what it should have been. And then my meter started being able to read the resonant frequency and the Q factor of the inductor. And when I put it in the amp, worked perfectly. No more hot MOSFETs, no more hot inductor. Yeah, all good to go. Shame I didn't stream that one, but yeah, I was kind of busy that day. Pete says, now you got those Martin Logans, when do we get to see you dig into that amp? Like that's just the side project. So yeah, whenever I get some free time, like you know, like a whole day to myself or something like that, I'll do it when I feel ready to. I'll do it when I feel ready to, and I'll do it when the time feels right. At the moment, they're running off my SUV 650, but I do want to obviously repair the massive chapter 2 amplifier, and I want to do it on stream. But I just need to kind of do it when the time feels right, work up to it, because I think it's going to be a bit of a headache. But today's just a chill Sunday. I don't fancy doing that today. What do you think about Soundstream T515s? Not sure. Haven't really had much experience with those, I'm afraid. Can't really tell you much about them. What time is it there? It is 3:54 p.m. Eddie says he wants to send me an equalizer. I don't take work from overseas, so if you're in the UK, then no worries. But yeah, you're in New Jersey, so yeah, unfortunately I won't be able to help you there. But there's plenty of really competent technicians you can go to in the States. Just ask on the Facebook forums and people send you their way. Have you ever thought of putting a stick on the camera from your ceiling instead of using that silly head rig? Well, the hat cam is kind of cool sometimes. The overhead cam doesn't always capture stuff, so this is basically camera on stick from ceiling, except it's not on the ceiling, it's clamped to the desk. So this is useful, and this zooms in nicely. But sometimes the hat cam is kind of cool if I'm doing something else, or you know, want to show you guys. It just gives you a perspective from my own viewpoint. So I like to switch up the cameras. I like to keep it very active with different cameras. This is the oscilloscope cam that obviously works when the oscilloscope's on. I also have the hat cam. I did have another camera that was way off to the side to give you a more overview of the workshop, but I've since moved the workshop around and I haven't got around to plugging that camera back in yet. But I like to keep the live stream switching up with the cameras. It feels gets less stale, I think, if you keep switching the cameras up, getting different perspectives on things. Not sure what your stream settings are, but the compression gets pretty bad when you switch to the other cams for a moment. Switch to other cams with movement. Interesting. So on my screen here, it looks pretty good. I can check it out. At the moment, I am only at 4,000 kbps. And that is literally, oops, gone to studio mode. That is literally just down to my computer settings, I think, the computer hardware. I'm streaming at 60 frames a second, and I don't think it can really manage much more than about 5,000 kbps. Let's try it. Let's try going up to 7,000, and let's see if that looks any better. But it could also be your settings on your side from YouTube, but it could also be YouTube's YouTube settings as well. YouTube will obviously compress this. And also I have the stream set to low latency. When you have the stream set to low latency, it means that I get to read you guys chat much quicker. It's more interactive, but it does mean that the quality suffers. If I set the stream settings to normal latency, the stream will look better for you guys, but there's a 40-second delay between when you type on the chat and it gets to me. So it's kind of a bit too slow for good interaction. So yeah, I've changed the bit rate up a little bit now, although it doesn't seem to have updated much on the. Actually, it's still saying it's 4.5K, even though I've changed it to 7 in the settings. Not sure why it hasn't updated yet. Come on, guy. Output 7,000. Yep. Okay. Apply. No, still at 4,000. Oh well. Corn Pope stealing my boyfriend. Ah, it is what it is. What can I say? Irresistible. Bevers, I remember you saying the AAB, SFB amps 12k and up will go pop if you try and set the gains without a load. It's not a guaranteed, but those amplifiers, the filter network on the output side kind of relies on there being a load connected to the amplifier in order to not have the risk of breaking down the filter network and shorting the output FETs. I've seen it time and time again, people running the amplifiers, testing them first or setting their gains without a load connected, and the output section just pow, because the filter network breaks down without the load being present. So it's not a guaranteed failure every single time, but there is a high risk of that happening. So it's not just the bigger stuff as well, the smaller stuff as well. Any of the Chinese Sound Digital clones, and even the Sound Digital themselves, and for that matter, any Class D amplifier isn't really great running without a load connected, even idling. So yeah, I wouldn't recommend it. How would I set the gain without having subs attached? You attach the subs. You should probably be setting gains with subs attached anyway, because when you have a load attached to the amplifier, your gain position will change. Your gain point, your clip point will change. As soon as you hook up your subs or any load to the amplifier, the clip point is now lower than it was when you didn't have your subs connected. So you should always have your subs connected when you set your gains. But obviously be sensible. If you've got a 12,000 watt amplifier and your subs aren't able to take in that much power, then don't set your amplifier up to clip point like that. Just start nice and low and keep increasing the gain with your music. You know, take like 10-15 minutes to do this process. Play a range of music and keep increasing the gain, and you'll hit a limit, and that limit will either be the clip light flashes, at which point great, now you found your clip point, or the other limit will be that the woofers move to their mechanical excursion limits. Great, you found your limit, now back off a bit. The third limit will be that the subs start warming up a little bit on the dust cap, or you start to smell the coil a little bit, and then you back off a little bit. That's your limit. You don't need to set the amplifier to clip point for every single system, and you don't need to do it with a tone in a burst. You can take your time. So do it with your subs connected. Annabelle, man, thanks for the $10. Appreciate your videos. I know it's nothing to do with Amplifier, but can you show my pictures when you get a chance? Oh crap, sorry, yeah, you did send some pictures through. Sorry about that. Let's have a quick look. Got a few emails come through. We've got Annabelle here on the emails with an LS swap, apparently. Damn. Is that a Chevy? That is a Chevy, isn't it? We have Chevrolets in the UK, but they are the most boring, rubbish Euro boxes you've ever seen in your entire life. We've also got this picture come through from David Kozlek. Wow, some nice snow here. That looks beautiful. That's like kind of cabins, like some kind of nice hut situation going on here. Really cozy vibes. Lovely blue sky with the snow on there. Looks really nice. That is Grand Rapids, Grand Rapide, whatever it is, Michigan currently with the snow. Nice. Thanks for sending that in. And Annibal says not finished yet. I think is this the LS swap again? Yeah, look all the leaves. But yeah, wow, that's pretty cool. Like, I have no idea what I'm looking at here. I don't know anything about engines at all. So, I mean, that's an alternator and that's a battery. Yep, looks good to me. Sweet. Thanks for sending those in. Right, anyway, what I want to look at today is not actually an amplifier repair, but I think you'll find it really interesting because it is audio related and it is bollocks. It is nonsense. And we're going to fix it because it was driving me nuts. Right, guys, a bit of story time. I'll get back to your live chat in a bit. So, my parents love listening to jazz music. They love listening to jazz music, and there's a few internet radio stations that play really great jazz music. A lot of them based out in the States, actually. So I got them a couple of internet radios. These are little internet radio boxes. So they're tiny little media players. They connect via Wi-Fi. You turn them on. You navigate to an internet radio station. and you plug in an audio device like an amplifier, connect it to your amplifier, speakers, whatever, and it's, yeah, just literally an internet radio player. These sound like absolute dog crap, by no exaggeration. These are horrible sounding things. To the point where, like, usually you need to hear a difference in how bad something sounds. Usually, if you to notice it, you need to hear like a good version of it, and then pretty soon after a bad version of it, like whether it's a bad quality recording or like a low quality MP3 or something like that. Usually, you don't notice it like instantaneously, but every single time these were put on, I was like, it sounds like crap. I was like, the tweeter's even working. I was going up to the speakers like thinking, oh crap, what's up with the tweeters? It just sounds muffled. It sounds very lacking. No detail. Hi-hats, cymbals, gone. No high frequency response whatsoever. So I was just of the assumption that these things were just rubbish and they had like an extremely poor quality DAC in them, digital to analog converter. So it's converting the data, the stream, audio stream, into a really low quality analog wave, and was missing a lot of details and the highs and stuff like that, or that it's just picking a very low quality stream from the internet. However, I was talking to a few people, and it's kind of come about that even the worst quality DACs, even the worst quality digital to analog converter chips, don't sound that bad, don't sound noticeably bad. They still have pretty flat response from 20 to 20k, because that's what it's designed to do. Why would any company release a DAC chip if it like started rolling off at like 11k? That wouldn't really be a thing, right? So I looked at this DAC chip and I was like, this chip has been used in other devices that don't sound this bad. So I was like, right, so maybe it's not the DAC, maybe it's something else. So I pulled it apart to try and find out why this thing sounds as bad as it does. And I think I found what the issue is, but I don't know for sure yet, and we're going to find out together. So this is the little board for the internet radio. We've got the screen on here, got the Wi-Fi module over here. I don't know what this is, maybe some kind of, I think there's Bluetooth maybe, it's got an antenna there as well. Not entirely sure, don't really care too much. No buttons on the front, you have to use the controller with it. So there's a little IR receiver. Probably a couple of buck converters here. Looks like I've got a little 5-pin buck converters, maybe. Don't know, haven't really looked too much into it. Got the audio input board here. And then on the back, probably what is the DAC, maybe, or the processor or something like that. This could be a digital volume chip, digital potentiometer, something like that. Haven't really looked too much into it. But what I was interested in is I was interested in some components that are on the board down here by the audio output jacks. So I looked at the audio output, and it has an audio output and a headphone jack, and the audio is the same. It's terrible from both. And I was like, oh, okay, let's trace back where this audio comes from. So what I noticed is that it goes obviously through the audio jacks here, and then it passes through these. Now these little black blobs, which look like resistors, maybe I'll get the microscope out for this, it might be easier, but I think you can kind of see there. These are little ferrite beads, or they're little inductors. So the purpose of these is to filter the audio wave from any high frequency noise generated by the rest of the circuit. Any like switching from buck converters or pulse driven stuff or data line stuff that, you know, could leak out from the rest of the circuit and find its way onto the audio path. Now my thought is that actually, hey, when they were designing this, they've used too intense an inductor, and instead of just filtering out all the pulses and all the sort of high frequency noise from the rest of the circuit, it's probably filtering out some high frequency audio as well. So that was my thought. So let's test it. I haven't tested it. So I'm going to plug it in and get it connected up to my Wi-Fi here. Or actually, what I might just, yeah, I'll get it connected to my Wi-Fi, and well, no, it'd probably be best to actually plug something in via jack, wouldn't it? So we can actually give it a solid test tone. So if I can find a jack to RCA cable or something like that, I can plug in. What can I do? Oh, I can plug it in from my PC. Here we go. We'll get Audacity open on the PC, and we'll plug it in via that. Just bear with me a sec. I'll go under the desk here. Grab an RCA from. Oh, no, I can go out from the Technics actually, can't I? So I need a jack to jack lead in order to test this out. So I might just go and grab one of those. Jan says, in your last stream you mentioned Paraflex enclosure design. This design is new to me. Can you explain shortly how it works? I can't, unfortunately. I don't know much about them myself. There is a great Facebook group which you can join, which is it's basically a Paraflex design group. It's the guys who kind of come up with the idea or are prototyping further designs based on the Paraflex. So there's lots of insanely knowledgeable guys in that group, and it's most of the designs are for pro audio PA applications. So it's all rigging, it's all like big PA rigs and gigging and stuff like that they're designed and built for. But they are monstrously great enclosures and have been used in car audio as well. So yeah, I don't know too much about how they work. I wouldn't know where to go about designing one myself at the moment. I haven't researched it enough. If I researched it, then yeah, of course, absolutely, I could figure it out. But I haven't looked into it. But yeah, do some research on Paraflex. Partner says, you are by far the most knowledgeable dude on YouTube about this stuff. High compliment from him. Oh, I appreciate that. That's really cool to hear. I'm probably not. I'm very good at giving off the impression of knowing a lot about stuff. I'm very good at blagging my way through things. So it probably sounds like I know a lot about what I'm talking about. But sometimes I do know what I'm talking about a certain subject, but sometimes I'm kind of guessing, I'm making educated guesses and saying it in a way that makes it sound very believable, and sometimes it turns out to be the truth, sometimes I get it wrong, but I'm very good at sounding like I know what I'm talking about. If you set clip point on an amp at half volume of the, R748 SPX, if you set the clip point on an amp at half volume of the clip point, are you losing any performance from the amp? I don't know what that means. Half volume of the clip point, what do you mean? Or is it best to set the amp and heads unit clip point at their maximum? Are you talking about the head unit clip point and the amplifier clip point? So you're not losing any performance, no. The amplifier is going to be producing its maximum output when it clips, regardless of what signal you're giving it. If you're giving it 0.2 volts worth of input signal and you've got the gain cranked up to full and it clips, versus if you've got the head unit giving it 4 volts signal and you've got the gain level right down and it clips, then no, the amplifier is still producing the exact same output. Doesn't make any difference. All right, let me go and grab a jack to jack cable and we'll have a look and see how bad the frequency response looks like of this, because I think it's going to be hilarious. I think it's going to look absolutely terrible. Wait, does this have an audio input? Oh, it doesn't. No, so I can't actually give it. Oh hell. Can I connect via Bluetooth? Right, let's turn it on and let's see whether we can actually connect via Bluetooth so I can give it a sine wave. All right, here we go. Doesn't actually have an audio input, does it? So oh, in order to get this to turn on, I think I need to bridge over these connectors. Yeah, we do. Okay, let's turn that off. It's got a little power switch on the back and it just bridges over this this connection here. So let's just do that. Switch that on. Okay, here we go. Welcome. Welcome. Well, he's a computer engineer with an IQ of 191, so he knows when people know what they're talking about. So, well, I appreciate the compliment, thank you. There's definitely some things that I blag in advance, like I think my brain goes, oh, it must work like this, and I then make a very, then make a statement that it works like how my brain thinks it does, and then I go check it after, and sometimes I'm right. Okay, so we're going to connect it to, can we Bluetooth? Can we Bluetooth to it to show you guys how terrible this is? Would you like to configure network now? No. Okay, here we go. Internet radio local configuration. Ah, yes, Bluetooth. Woohoo! So let's get my phone open and let's get a frequency generator. Scan for devices. So yeah, one of these is Bluetooth, one of these is Wi-Fi. I'm not sure which one of these is which. Let's have a look. We've got the, I think Bluetooth is a shorter wavelength, isn't it, than Wi-Fi, I would assume. So that one's probably Bluetooth, that one's probably Wi-Fi, because the antenna is much larger there. Okay, yeah, Bluetooth. Is it going to find it? What the heck is UPnP, Universal? No. Bluetooth. Come on. Where are you? Typo says same wavelength. Oh, interesting. I wonder what the reason for the different shaped antennas is. Well, the antenna for this one is built into this daughter board. So this board wasn't designed by whoever designed this main board. So maybe it's just a difference in... oh no, that's a TV. Oh man. Do I need to do something to make it give out its... Is that a copy of Logitech Touch? Not sure, no idea. It's just some kind of generic thing. WR01C. That looks like it might be this. Is that? Pair with, yep. WR. Oh yeah, here we go. Yeah, finally came up. It just was very, very slow. Okay, there we go. We are connected and we have Bluetooth. Excellent stuff. Right, now let's turn the oscilloscope on for the first time today. Or maybe this is 5 gigahertz Wi-Fi then. I don't know. Maybe it's just a difference in the design of the antenna. But either way. So now we have that. We're going to go ahead and open FuncGen on the phone. Sine wave. And we're going to start and have a look at what this looks like. Let's get the oscilloscope connected. Okay, so the output is probably going to be one of these. So let's start with 500 hertz and turn the scope settings correctly. I'm going to want about 5 millisecond divide. There we go. Reject high frequency because we're starting with low frequency. And I'm probably going to need to connect a ground reference. Yeah, it looks like we have a bunch of noise on there. So I'm going to have to hook up a ground reference to my scope here because this device will currently be floating. So where is ground? Where is ground on this thing? Is there a nice big ground pad I can clip to somewhere? Yeah, there is actually. Nice big... Oh no, that's actually part of the main input. Let's have a look on the back here. Can I connect to ground nicely through here? What have we got? Okay, I would say that that is probably ground, that one right there. Can I clip onto that nice and easily? Yeah, there we go, there's ground, okay. Let's get my long boy. There we go, there's my long boy. Yeah, just a chill Sunday, so we'll look at some amps in a bit, but I was really curious to see what was up with this thing, why it sounds so crap like it does. Right, does that connect to ground? Just about clip that on there? Does it just about reach? Okay, so that should now give me... Nope. Trying to find a ground reference for this. There we go, there's our ground reference. Okay, great stuff. So I don't know if my crocodile clip will stay on there super easily, but there's my ground reference. So let's have a look for the audio wave. We need 500 hertz coming out of this thing. There we go, there's our 500 hertz coming out. Okay, now we can start to look at this. So let's crank the volume up. Volume is on full, volume is on full. Zoom right in. Turn my probe down to ×1. Okay, there is our audio output. Has a little bit of DC offset on it, but that's fine. Nothing we can't deal with. So looks nice and clean. So let's just take a reference. 500 hertz. What is the waveform amplitude of that? We have a 7.2 volt RMS waveform for 500 hertz. Okay, now technically we should be able to go all the way up to 20 kilohertz, and that shouldn't change. We should still have a 7.2 volt RMS sine wave on the output of this. So let's start going up now. Let's go up to 1 kilohertz. On the phone signal generator here. So we've dropped down to 5.9. Let's go up to 3 kilohertz. Oh, we're all the way down at 4. Let's keep going. So the voltage starts dropping off. Oh my gosh. Hang on a minute. Let's go down to 100. Let's go down to 200 hertz. So 200 hertz, we have a nice clean sine wave, 7.4 volts RMS. Okay? By the time we get to 800, we've gone from 7.2, we're down to 6.7. As we increase to 2000 hertz, we're now down to 4.7. There's 4.7. If we go all the way up to 5 kilohertz, or actually this is 6 kilohertz, we're down at 2.3. That's 5 kilohertz, and we've lost so much voltage from 7.2 down to 2.4. If we keep going even higher, let's go all the way up to 12 kilohertz. We have basically nothing, 1.2 volts output. I want to see if I can keep my oscilloscope probe hooked on here as we here we go. So I'm gonna sweep the phone here. Ooh. So the output should be about 8 volts. 8 volts RMS output from this device. But as we go up in the frequency band, it absolutely disappears. Now what I wanted to know was, is that just a really terrible DAC, digital to analog converter, or is that as a result of these little ferrite beads, these little ferrite inductors in here that are filtering between the board and the jack terminal actually causing that? Because if it is, then we can just solder across them and bridge over them. So let's have a look. So we should have... Okay, there's 3.9 on one side of that inductor. Oh, you know what? It's not. It's actually the same amplitude on both sides. Rare. So where is that low pass filter being applied? It's awful. I thought that it was going to be those little inductor beads. But maybe it is something just really, really awful DAC. Right, so let's have a look a bit further down the circuit. We've got R40 here. So we've got 4 volts on 2 kilohertz. Let's go down to 100 hertz again. .4. No, yeah, so it's happening way back here, way back in the circuit here as well. What about these capacitors here? Capacitors are high-pass filters though, so it shouldn't be that. 7.4. We've got it either side of these capacitors. We've got 7.4 volts. If we go up to 1400 hertz, we've got 5.8 volts on one side, 5.7 volts on the other side. So yeah, it's passing these capacitors just fine. Where does it come from? Okay, maybe it comes from this chip up here. Maybe this is a digital volume chip. Maybe this is causing some issues. So let's have a look. See if we can find a sine wave on any of these pins. Ah, there we go. There's a sine wave. Okay, so we have 5.9 volts there. So basically what I'm doing is I'm working my way backwards through the circuit, and I'm trying to find somewhere where the audio wave amplitude is the same across the frequency band. So we're trying to find out where this strange low pass filter is being applied. So yeah, here we have 6 volts at oh, actually that's much higher than it was before. 1428. We've got 6 volts. Let's go down to 190 hertz. It's a little bit higher. 7.6 volts. What about if we go up to, say, 3 kilohertz? No, so it's still dropping off. Got 3.9 volts. It's a bit better, but it's still massively lower than the lower frequencies. So it seems to be either before or after this chip. So let's keep having a look. So we're looking for a nice higher voltage with this higher frequency. More than 3.6 volts, I would say. Let's just go down to 100 hertz again. That's back to 7 volts again. On the low frequencies. Back down to the low voltage on the high frequencies. Okay, yeah, not that. Got some DC there. Got some ground there. Ground. Got a bit of... now this might be the input to this chip, because that is even lower still. So that was 2 volts with a high frequency. If I go back down to about 120 hertz again, got 7.2 volts. So no, it's still changing there as well. .4 volts. No, okay, so I think that the low pass filter is before this chip, and this chip is probably a digital voltmeter. 1.4 volts going into this bottom chip, bottom leg here. 2 volts. 2.1. That's mega low up there, isn't it? Okay, so maybe trace back a bit further then. You know what, I thought this was going to be nice and simple. I thought I was just going to be able to bridge over these inductors down here, these tiny little ferrite bead inductors by the headphone jack, and that would sort it. I thought that was probably the issue, but it seems that it's way further back in the circuit. I honestly still think we're looking for some poorly chosen inductor value, to be honest. Because what else would work as such a low pass filter? It's got to be some kind of filter inductor somewhere on the board, because the DAC wouldn't do that. This chip wouldn't have such a ridiculous, like, that chip would just never be usable in anything. Right, what about coming out of the Bluetooth? Right, because if we flip the board over right here, we have obviously some daughter boards on here. We've got the Wi-Fi and the Bluetooth. So we're connected at the moment via Bluetooth. So I suspect the Bluetooth module might have its own DAC built in, and it's just passing it through the preamplifier output of this. Now, what's that? Some kind of clock signal, perhaps? Or is that the audio? Is that the audio in pulse waveform? Let's stop the signal here. No, it's the same whether we stop or start. So that is just some kind of clock. That's not actually the audio. What about up here? Ground. Nope. Not that. Okay, what about over here? Maybe this is the Bluetooth module. Yeah, this is probably the Bluetooth one, maybe. I don't know. Let's have a look. Let's probe some of these pins. Aha! Okay, I found audio outputs here. This one over here, this is the Bluetooth module. So we have 5 volts coming out of this. And is that the same regardless of what frequency we're playing? Yes, it is. Okay, so we've got 5 volts coming out of this Bluetooth module regardless of the frequency. So the Bluetooth module is good, okay? See that? We've got 5 volt RMS up at 4 kilohertz, 5 kilohertz. If we drop it down to 450 hertz, again we've got 5 volts RMS. So we know that the Bluetooth module, the audio output from the Bluetooth module is fine. So where does it go through? What is causing that low pass filter on the main board? So this is your audio output, left and right. So let's try and follow these traces. They go on the underside of the board. Let's try and follow the traces. Follow the traces. Hey, you got to follow the traces. Yes, please. So a capacitor would be a high pass filter, so I don't think I'm looking for a capacitor here. Okay, so those traces from the Bluetooth module, they go through a via. Now I think the problem is this is a multi-layer PCB, so they go through a via, but then it doesn't pop out on the back side of the PCB here. It's probably going through the middle of the board somewhere, but it's over this side over here is where it seems to. Oh wait, there we go. No, there's our audio. 4.9 volts there on this capacitor. This little surface mount cap. Okie doke. And so, okay, so it's going through the surface mount cap. We're losing about 0.4 of a volt through the surface mount cap at low frequency. How about at high frequency? 5 volts. 4.8, no. So we're not losing significant voltage through that cap. Nothing like what we are on the outputs of this. So we go through the cap. We go through. Do we go through this resistor here? 3.7. So yeah, it steps it down a little bit. This resistor steps it down a bit. Here, this was 1K. Let's make sure it's stepping the voltage down. Yeah, it's stepping the voltage down the same across the board, I think. 4.4 volts at lower frequencies, and aha! Hang on a minute. Hang on a minute. What's this? Right, gentlemen and ladies, if there's any ladies. Anyway, well, I think there might be one lady watching. Or I don't know. I can't make assumptions. But anyway. See here, this is the output from the Bluetooth board, right? So when I play a 100 hertz tone, okay, or 130 hertz, you can see that we have on this side of the resistor, we have 4.5 volts. If we play a 6000 hertz signal, we have 4.9 volts, pretty much the same, okay, on this side of the resistor. However, on the other side of the resistor, a low frequency, we have 4.4 volts, but if we go and play a 6 kilohertz tone, it's suddenly nothing. So could that resistor be filtering or something, doing something bad with the audio signal there? Where does that go on to after this resistor? So we could firstly try jumping over the resistor. It's a 1 kilo ohm resistor, not really ideal to jump over. But where does that get sent? I think that gets sent on to this chip here, which I think is some kind of digital potentiometer, perhaps. I'm not sure. We can actually look it up. What is that chip? Let's get some thermal paste and rub it over the front of the chip so we can see the front, the sign a bit better. Signage. Do I have any thermal paste at hand? Usually I have mountains of thermal paste everywhere in the workshop, but has that made it easier to read or has that made it harder to read? T2354. Right, let's Google that. Shit. Let's Google that. What is that chip doing? Because I think that's where it goes next. Right. Oh, it's an ET. ET2354. Right, what are you? You are a stereo something or other, 4 channels. Is that going to work? Nope. It's a digital control audio processor. Oh no, don't take me to the website. Just give me that freaking PDF. Give me PDF, bro. It's a 4 stereo inputs, 2 channel output digital control audio processor for the low voltage operation. I love how the low voltage operation is a singular entity. Volume, tone control, bass, treble, balance processor are incorporated into a single. Oh, you know what? I wonder whether actually it's just that the bass is turned up really high on this, and then the treble is not turned up very high. Should we double check that first? That'd be hilarious, wouldn't it, if that is the issue? But why would it happen before and after the resistor? Right, let's just check the EQ on this. EQ normal, flat, jazz, rock. Okay, let's go flat. I don't know what normal is, but let's just go flat for a second. I don't think we can increase bass or treble individually. I don't think it lets you do that. Yeah, let's just double check. So now at the output, so it should be flat now, right? 2.0 at the high frequency, and yeah, no, it's not. It's nothing to do with that. It's nothing to do with that. Nothing to do with the EQ. Okay. So yeah, so this is the audio processor chip. Okay. So it looks like that whatever goes into this chip is already having the low pass filter applied to it that we're trying to get rid of. So it seems to does seem to be this kind of resistors over this area, because before it we have good amplitude across a range of frequencies for left and right. and then after it we have a massive reduction in the high frequencies. So guys, what I'm thinking is jump over these 1 kilo ohm resistors. What do you reckon? They've only got audio frequencies on them. What's the worst that could happen? Do you reckon jump over these 2 resistors here? See what happens, because where does that then go? We've got, it goes into a capacitor here to ground. Oh, that could be the issue actually. The issue actually could be these capacitors to ground. Because a capacitor passes high frequency to ground. I reckon it could be these 2 little surface mount caps here, you know. What are they doing there? Why are they sending our nice audio signal here to ground? So, 2 things I can do. Either I don't think it's a resistor. A resistor wouldn't act as a low pass filter. It can't be right. It must be nonsense. So I'm thinking, remove these 2 capacitors first, because we've got the audio signal on one side, and then it seems to connect to ground on the other side, or something, like some big ass trace down here. Typo. Yes, typo, yeah, I guess that's what I just found. Alright, so let's turn this device off and let's remove those caps, see what happens. So that is now off. We can now off this as well at the back of the switch and off it from the main switch. Whoa! What is that noise? That scared the living bejesus out of me. I flicked the switch, or I flicked the plug switch off for this device, right? And then all of a sudden this mental high frequency noise started happening. I was like, oh my god, what have I done? What's happening? It's the frequency generator on my phone. It disconnected from Bluetooth and it went back to the built-in phone speaker, hence outputting 4900 hertz at full blast. Fuck's sake. I was like, what? I was thinking like I accidentally grounded something, and that like high frequency noise was some nasty transformer grounding itself out. I was like, Jesus, what is that? No, it's just my phone. All right, cool. All right, let's get cracking on with this then. Let's remove those caps and see if that makes a difference. So where are we? There we are. These 2 here. Sorry guys, apologies for that. Sorry guys and girls, if there are any girls, but yeah, apologies. That was a bit intense, wasn't it? Don't remove all the caps. No. My intention at the moment is just to remove these 2 ones that are first in line, that have the audio signal on one side and appears to be ground on the other. I'm going to have to go back on and watch that later on the stream and see how bad that came through on the stream. It was probably loud as heck. First, test it with the multimeters to see if we're ground. I'm pretty sure it's ground. It didn't have the audio signal on the other side, so where else is it going to go? I think there's a few different ground references on this board anyway. Yep, it's ground. That is the ground terminal of the power plug, so yeah. No, where's my nice tweezers? My good tweezers. Does everyone have that? Everyone who has a workshop or works on electronics, do you have like your good tweezers? You know the ones. No, they're not my good tweezers. Like, Ah, here they are. Here's my good tweezers. Your voice distorted. Okay. Is my voice clipping anyway? I've actually just noticed here on OBS. Looks like my audio input actually does clip pretty bad. Maybe I should go ahead and reduce that down a bit. So if I reduce this down a bit, is that now lots better, or is it just the same but quieter? So if I go D, is that distorted versus D? It was fine before. Okay, cool. I won't change it then. Okay, we're going to keep them safe, just in case they're not the issue, because we'll put them back if they're not. They're very, very small. These capacitors are a little bit smaller than the average that you would work on, that you'd see in a car amplifier. Okay, so they're out. Let's see now, if we plug them all back in, whether we have fixed the issue or just kind of like just getting there, you know, just kind of finding our way, or whether it's somewhere else entirely. I'd quite like to just jump over this, so I haven't got to have this great big plastic back on there. What can I jump over this with? A screw or something? Got a spare screw somewhere maybe? Oh, I can just jump over it on the back, can't I, with a solder? I'm just going to quickly solder over these pins on the back here so that I don't have to have that connector plugged in at all times. Are you trying to remove the high pass or lower the minus 3 dB? No, so I'm trying to get rid of whatever issue on this board is causing there to be a massive steep low pass filter slope that basically causes there to be a huge lack of high frequency response from this thing. There we go. That should now come on fine without needing to flick the switch. Welcome. Okay, let's connect it back up to my phone. Bluetooth. Mode the Bluetooth, please. Hello? Why is this now not working? Oh, it is. Would you like to connect to the network now? No. Oh, here we go. Bluetooth. There we go. Okay. Oh yes, and it connected instantaneously. Love to see it. Okay, FunkGen. Back to our high frequency stuff. Okay, so let's get my ground connected again to this and the back here. There we go. Okay, so let's see if we've solved the issue with the first mod, removing those two caps. So we're going to play frequency here. Ah, that already looks so much better. Look at that on the scope screen. We have 7.8 volts at 4900 hertz. Go down to 150 hertz. Oh, there's still some kind of low pass. So at 100 hertz we have 10 volts, and as we go up, it still does drop off. 8, 7. It drops off a bit, and by the time we get to 14, 15, we're down at 5 volts. So okay, we still have some filtering issue there. So now let's turn our attention back to this part of the circuit and let's see whether there's still a reduction in high frequency output. But it's much better. It's so much better than it was. Holy bananas. So much better than it was. But there is still some drop off on the high frequencies. So let's just see if we can see if it's still before and after these resistors, then it's going to be these other caps here as well. So let's go up to 13 kilohertz now. So 13 kilohertz, zoom in a bit on the scope so we can actually see what we're looking at. Okay, so before this resistor we have 4.9 volts. After the resistor we have 4.9 volts. Okay, now let's go down to 300 hertz real quick. We have 4.9. Okay, that's interesting actually. So 300 hertz, we have 4.9 volts there, 4.9 volts there at 275 hertz. Now if we go all the way up to 13 kilohertz, we have 4.9 volts. Well, it's 4.8, 4.9, 4.9. It's a little less actually, it's 4.8. It's like a touch less. I don't know if that would translate to as much of a reduction on the output. 4.6, it drops off a little bit, but not by that much. On the other side of the resistors, we now don't have any more reduction. 4.6 on one side, 4.6 on the other side. So removing those two capacitors definitely has resolved the issue at this point in the circuit. However, at the output side, we have 7.5 volts. Oh no, hang on a minute. We have different output voltage depending on whether we are coming out the headphone jack or the audio jack. Okay, so the audio jack output is on this side. So the audio out jack has what appears to be much higher amplitude, 7.5 volts out of the audio out, whereas the headphone jack is limited to 4.9 volts and 100 hertz. Oh wow, the headphone jack is still screwed. Okay, so the audio output jack is better. This is really interesting. So there must be another set of those capacitors somewhere that is that's not good. Okay, yeah, interesting. Right, let me just quickly, I think I actually just knocked a capacitor off here. I was noticing I was only seeming to get output from left or right only, mono. I think it's because I just knocked this capacitor off its pad slightly, so I'm just going to reflow that one. But I reckon there could be another one of these circuits somewhere else on the board that is also causing an issue, either for the headphone jack output or for both outputs. But that's now not quite as bad. Where's my good tweezers gone? I lost them again. Right, these are here. They are hiding behind my thing here. Let's just push that, get that back on for a second. There we go. Okay. Now we should probably also let that cool down a bit, because capacitors do change their values with heat. As they heat up, there'll be different values, so that could be skewing our results a little bit here. Thanks for joining, Sean. No worries. Catch you in a bit. So we know that it isn't the Bluetooth codec that's causing this drop in signal, because we scoped the output from the Bluetooth module on this board, and it was flat across the board. It was flat from 100 Hertz all the way up to 18-20 kilohertz. It was a flat, solid, reliable voltage. So the issues are on the main board. So it'd be interesting to figure out what it is. It could be this audio processor. I suspect this isn't particularly high quality, and even with the EQ set to flat, it could be reducing the amplitude on the high frequencies just enough. Thanks, Typo, for joining and for your advice, your tips and tricks. Let's have a look, see whether there's a frequency response table. Yeah, that'd be interesting. So this is the audio processor chip. It's only got one page on this data sheet here. I could just bypass it. Like, we don't need the EQ. I don't want any EQ. You know what I mean? Maybe I could just bypass it. That's all it seems to be, just one page. Yeah, it's just one page. DL, thanks very much for the wisdom there, my friend. I'm doing my best to enjoy my time. Yeah, this is all that there is for the datasheet. So we've got left in, left in 2. So we've got 4 channels of input. Is it? What is it? Four stereo inputs with selectable input gain, 2 independent speaker controls for balance, tone controls, loudness and independent mute function, volume control. Now, so I don't think we can bypass it. I think it's probably doing too much. I don't know. Maybe we could. We've got in, left in 1, left in 2, left in again, left out, B in, B out, B in right. What the heck? What? Why so many ins and outs? Treble left, treble right. Oh, that's bass. Bass, treble, loud. Okay. So we could remove the chip, find out where the audio signal is coming in, find out where it goes out with the chip installed, and just bypass it if we wanted to. But right, let's have a look on the board again then, and let's compare. What was I doing? Oh yeah, I was resoldering that capacitor that I knocked off. Right, let's turn this thing on again then, and let's see whether the voltage difference happens before and after this audio processor chip. We can take it out. It will just mean that we don't have any control over the volume anymore. I'd quite like to solder a little wire lead onto this ground pin if I can, or maybe just beef up this ground solder point so that my crocodile clips on better. Maybe if I was solder the crocodile clip to it temporarily. Now I'll just scratch away a little bit here. Scratch away a little bit the PCB, give my crocodile clip something to nip onto. There we go. Okay, so yeah, back on, power, connect up to Bluetooth. Yeah, the volume will be fixed, but it should work. Yeah, exactly. I don't really care about the volume control on this. I just want to be able to give it to my parents to use as a audio streamer for internet radio, and it actually sound good, because I've given them some quite nice speakers. I want them to make the most of them. No. Bluetooth, please. There we go, we're connected. All right. So audio here, audio here, audio here, audio here, audio here, audio there, audio there, audio there. Cool, cool, cool. So the reason that I didn't have audio on the output jacks a minute ago is because as we've been fiddling around with this, I think, look, you can see there, we've actually snapped the solder connections a little bit on there. See, the solder joints on there are bad now. That's fine, we can fix that later. All we need to do is just check the audio signal through the board here. So 100 Hertz, we have 4.95 volts RMS on the scope. So if we go up to 14 kilohertz, we still have 4.8, so it's a little bit less. Okay, no worries, but let's follow it through the circuit. 4.8 over here, 4.8 over here, 2. Okay, so then it drops down to 2 volts by the time we get to this resistor. So it goes through this capacitor, through this resistor. Now it's down at 2 volts. Okay, what about the low frequencies? So let's go back down to 100 Hertz. We were down to 2 volts. Down at the low frequencies. And 2.3. So we've got 2.3 volts down at the lower frequencies, 100 Hertz. And up at the higher frequencies, like 12 kilohertz, we have 2 volts. So we've lost 0.3 of a volt. And I think at this low voltage, I think that will make a fair difference. Now, obviously, we've got a resistor here, 4.8, 2.1. And we have another capacitor here to ground. So I'm wondering whether this capacitor here to ground is also causing a 0.3 volt reduction. From low frequency to high frequency. So we could try removing those as well. And to be honest, Typo Grandmeister is correct in saying that they wouldn't be here if they weren't necessary. So they probably are helping to reduce some noise from the signal path, but that's no good if we're losing like hefty amounts of signal on the higher end. So on the lower frequencies, 142 hertz, we have 2.3 volts, just to double check. And now if we go back up to the high frequencies, we have 2.1, so we're losing 0.2 of a volt there between the lower frequencies and the higher frequencies, which might be enough to translate to a fair difference on the output side here. So let's compare the input and output of this audio chip thingy mablobby here. So let's have a look at the pin out of this, which is this bad boy. So we seem to have a bunch of audio in and outs. Left in and right in. R in 1, 2, 3, 4. L in. R in is 5. L in is 17. That should just be our most basic forms of left and right input, shouldn't it? Pin 5 and pin 17. So pin 1, 2, 3, 4, 5. Here's our pin 5. Wow, pin 5 is 8 volts. So somehow it's gone up again. And pin 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Again, 8.3 volts. Let's have a look and see whether that changes with the low frequency at all. 1, 2, 3, 4, 5. 8.3 volts, about the same. Okay, so that seems to be about the same. Let's check it before and after these inductors now, on the back here. So if we go down here, you can see there's some little inductors here. So on the lower frequencies, 230 hertz, we have 9.8 volts. And on the other side, we have 9.8 volts. On the higher frequencies, 14 kilohertz. We have oh wow, 5 volts. So that's still heavily, yeah, that's still, we've still got heavy low pass filter applied somewhere. Ooh, it is extremely heavy. Above, this time it's in a different position. See here, now we have good frequency response, good level frequency response, okay, from like 100 hertz up to, we've got 2000 hertz there, 8 volts out, 7, and then as soon as we go above sort of 3 kilohertz, we start dropping off heavily again. 7, 6, 5, 4, 3, all the way up to 15 kilohertz. We're down at 5 volts, so we're still dropping heavy voltage there from somewhere on this board, somewhere else. Okay, let's have a look at this this chip here again. Let's see whether that is the case going in. 1, 2, 3, 4, 5. Yeah, we are dropping some voltage there. We are dropping some voltage there, but it doesn't start until you get to about 12 kilohertz this time. So it seems that everywhere on the board has a low pass filter applied somewhere along the board. 8.3 volts down to 7.6. .6 down to 1.8 versus 2.2. So yeah, I think that these caps are doing some business as well in reducing the high frequency response. So I know that it'll probably add a bunch of noise to the circuit, but I'm going to try removing those just to see whether that goes away. And if it does, if we get better high frequency response with those, oh, sorry, did it again. If we get better high frequency response with those removed as well, then I will replace those capacitors for something that will still filter the radio frequency noise, the high frequency noise, but won't affect the audio signal. Some smaller value capacitors. Seems to be a fairly popular stream. It's like 100 of you guys watching right now. Pretty cool. Let me know if you're enjoying the stream, guys. It's a little bit different to normal, but I think it's kind of interesting what we're doing. Okay. Welcome. Connecting to network. I don't want to connect to this network, please. Just give me the Bluetooth already. Come on. Come on. No. Bluetooth, please. Grazie. You told me the Bluetooth was connected just now. There we go. Now it's connected. Okay. So once again, we're comparing the low frequency to the high frequency amplitude over here at this part of the circuit. So we are after this resistor now. So low frequency response, sort of 1000 hertz. What do we got? We got 2.1 volts, and let's increase it. 2.2, 2.2, 2.0. Yeah, it's dropped off a bit. Well, it drops off heavily actually as soon as you go up to 20, but that could be the Bluetooth. I reckon that might actually be the Bluetooth module that's doing that drop off there, that very, very upper end drop off at 20k. That's fine. We can't hear that high anyway. Nobody here, I guarantee, not a single one of you in the live chat right now can hear above 18 kilohertz. I guarantee it. So that's absolutely fine. I don't care too much about that. That's probably the Bluetooth module dropping that off, and we can confirm that by flipping it over and probing the output from the Bluetooth module here. So we have 5 volts coming out at 6 kilohertz. Let's go all the way up to 19 where we were before it was dropping off a little bit. 18.3, 4.5, and all the way up at 20 we have, yeah, so that's the Bluetooth module doing that. So I don't care about the sudden drop off at 18 to 20 kilohertz. That's just the Bluetooth module. That's fine. What we care about is what this amplifier is doing to the sound, or the preamplifier, sorry, is doing to the rest of the audio waves. So let's go back and probe our little inductor beads down here before the jack terminal. Okay, now here we go. We have a nice nice big sine wave there, 7.7 volts. Now let's go up the range and see whether it drops off considerably anymore. We've got 7.8, 7.7, 7.8, 7.5, up at 8 kilohertz now. Yeah, it's still dropping off pretty bad. So there's some other filter somewhere as well that we've got to try and find. Okay, so removing those capacitors that we removed just now didn't really help this. So there's some other filter somewhere else as well we've got to try and find. Because this is well within the audible range. This is like 12 to 15 kilohertz. That's the nice upper end stuff of the tweeters. Alright, let's have a look. What else we got then? So we've got the output from this thing here. Like I said, I don't think that this is causing it. I think the issue is after this audio processor. 1, 2, 3, 4, 5. So we've got 8.2 volts going in. Yeah, that's absolutely fine. 15 kilohertz. Yeah, that's absolutely fine. So this isn't causing it. What about the outputs of this? The outputs of this chip for the preamplifier stage is going to be, let's have a look at the data sheet. We've got lots and lots of outputs here, but I'm going to assume we're looking at the most basic output. So pin 18 left out and pin 23 are out. I assume that that's probably going to be, hang on a minute, L out and out L. What's the difference? Pin 24 versus pin 18. This is all the data sheet. There's no other description or anything. This is the only data sheet we can find for this. So we don't have descriptions of each of these pins. So out L, out R, or lout. Is there a route? Is there an R out? L in L. No, there's not a route. So there's a lout, but not a route. So I assume that the main outputs are going to be pins 24 and 23. L out, out L, and out R. Pins 24 and 23, which is the 1, 2, 3, 4, 5th and 6th one down from the top. 5th and 6th one down from the top. So we got 1, 2, 3, 4, 5. 8.1 and 8.2, so no, we're up at 15 kilohertz. So this chip isn't the thing that's causing the issues here. Okay, let's continue on. Let's continue on. Where does the audio wave go after this chip? 1, 2, 3, 4, 5, and 6. Does it go to, right, it goes to this capacitor here. This cap, and these 4 capacitors here. Okay, let's have a look. What do we got after the capacitors? The capacitors are passing the high frequency, as you would expect. Then we have these resistors here, 8.1 to ground. Okay, looks good to me. Now, where do we go after that? Does it go down through a via? Possibly. Bunch more circuitry. Got a couple of capacitors over here, perhaps. No. I'm looking for capacitors to ground. What about this over here? 5 volts. 5.3. 5.7. 5.7. Here's a couple of capacitors to ground. I wonder whether these are doing it as well. There's a couple of caps to ground down here, surface mount ones. Okay. I can't quite see where the audio signal comes in before those caps. We've got these big ones here as well. I don't think these are doing it because these have the audio signal on both sides. What we're looking for is a capacitor to ground, because a capacitor to ground will actually send higher frequencies to ground, whereas a capacitor that's got audio wave on both in and out of the cap, that's not going to be reducing the high frequencies. If anything, it's going to be passing the high frequencies even better. So that's not what the issue is. So these big ones aren't going to be our problem. I think our problem is probably going to be these smaller ones down here. So let's pause my phone first this time. Yep, phone is paused. No more beep. Turn off the device here. And while we're here, let's reflow these soldered connections that have started to crack a little bit as we've been working on this. Let's remove those two surface mount caps and see whether that solves it. Why do companies make high-res amps that will play up that high if you can't hear it? Because there is some argument to say that even though you can't hear the fundamental frequencies of that go that high, there is some argument that the fact that they're there adds something else to the sound. So even if you can't hear a 20, 25, 30 kilohertz sine wave, you can't reliably say it's on now, it's off, it's on, it's off, even though you can't actually hear the sine wave, there is some argument to say that the fact that that information is present affects the rest of the listening experience in some way that makes it sound nicer. I don't know how much truth there is behind that, but that is what the argument is for super tweeters and super high resolution stuff that's up to 40k. I think it also means that when the amplifier is playing 20 kilohertz, it's much further away from its limit than other amplifiers. Like if the amplifier is capable of 40 kilohertz, then playing 20 kilohertz is like, walk in the park, no problem at all. Whereas if an amplifier is rated up to 20 kilohertz, then it might start to add some kind of attenuation or artifacting, or might be a little bit harder for it to play the 20 kilohertz than an amplifier that is rated for 40. I'm personally not convinced that having information that goes up that high adds to the listening experience, but I can't prove otherwise. That's just my personal opinion on it. There is a route, Sam, you missed it. Did I miss the route? Oh, my bad. God damn it. Why does the solder not want to take to this pad? Come on, mate. There we go. I'm just reflowing a lot of the connections on here because they're using some really nasty, probably lead-free solder, and it's yeah, it's just not the nicest stuff on there. Right. So I just want to try removing these two surface mount caps in here because they look arguably distinctively similar to the ones that we removed over on this side of the board that actually made a big difference and made a big improvement. And probably what I'm going to do is I might actually refit the caps that we removed, the second ones, these two, because they didn't really seem to make a difference. But I'm going to remove these two first, see what it's like. Then I'll refit these two caps, the ones we removed second, just to see whether that causes any issues with the signal response after we've rectified the main problem here. So these are our third caps we're removing up this side. But the thing is, right, this can't have been quality tested. Do you know what I mean? Like, after this board was designed, who the hell sat down with this and a pair of speakers or headphones, listened to it and said, yep, that's good to go. Make 100,000 of these bad boys. Like, how the hell did this thing get through QA? Like, not just this one, they're all like this. This is a design flaw, not this one. This isn't a fault, this is a design flaw. Okay. So that's those two caps removed, and let's power it back up. See whether we now have equal audio response across the range. Because I've got two of these, that's the thing, a lot of you probably don't know, I've got two of these, and they're both exactly the same, they both like it. Oh, come on. Bluetooth, yep. Wait for my phone to connect. There we go, device connected. Okie dokie, let's start off at 1800. Well, actually, let's start off at 3200. 3200 hertz, let's start off at. Let's probe the audio coming onto this pin. Let's get the ground wire hooked up as well. Okie dokie. Start. Okay, so low output we have 8.3 volts, 8.4 volts RMS at 3200 hertz. Let's go up to 14 kilohertz. Ah yes, we have 8.1, 8.2 volts. There it is, guys. There it is. Manufacturing design flaw fixed. Hey! Awesome. So, like I said, I am tempted to put back in the two capacitors that we removed second that didn't really seem to affect it. That being these two up here, because it does probably need some filtering of some sort. I didn't see any crazy noise on the oscilloscope there from any of the rest of the circuitry causing any interference, so I don't think it probably needs those surface mount filter caps anyway, but I will listen to it with some speakers in due course, and if it is really noisy and there's a bunch of feedback on, you know, there's a bunch of like noise on the signal, then I will probably open it back up again and fit some correct capacitor values. Now let's listen to it. Yeah, we could listen to. Well, I don't know if we can listen to it because copyright, but I might have something on my phone that is copyright free that I could play. Basshead's Anthem is the first thing that comes to mind. It's my own track that I made years ago about audio and stuff. So let's just freshen up these solder pads on these two here. Let's put these back and let's just see whether it runs fine with these capacitors in place. I'm well happy about that. Can somebody send me a link to some copyright-free music I can open up on my phone real quick? What should I connect to? An amplifier of some kind I've got here in the workshop? Right, it's that capacitor back in. There we go. Okay, so that's those two caps back in. I'm going to let it cool down because the value of the capacitor will change with heat. Oh yeah, I could just go on to SoundCloud actually. I know some tracks that are royalty free. I could go to Epidemic Sound, couldn't I, on my phone? That's a good idea. The only thing I will need is I will need some speakers and an amplifier to quickly test it on. I have lots of amplifiers, but most of them are dead because that's the point of this workshop. I've got the JL Audio 5 channel that I fixed last night, the other stream. Could connect it to that real quick via headphone jack. Okay, so those second capacitors that we removed are back in. I just want to reconnect it now and just see whether it's still nice and flat response, because if it is, then I'll leave those caps in, because it probably could do with some filtering of some kind. So just let it power back up again. So the sand is an interesting idea. However, the problem is with the sand is that the sand will accumulate on the waves that are riding along the surface of the material. So obviously the material will vibrate a little bit, and so the sand will accumulate in those places. That's not what we want. We want to find where the pressure peaks and valleys are in the actual air inside the enclosure. And I think sand is too heavy to be affected by the air in the enclosure. I think it will just accumulate on points on the surface that are resonating rather than points in the air that are high versus low pressure. So I think it needs to be something lighter, like polystyrene balls or some kind of smoke vapor, something like that. Okay, 16 kilohertz. Let's have a look and see if we're still good with those capacitors fitted. If it reduces it even by a little bit, I'm just gonna take them out. Okay, we have 7.6. I think it's reduced it. 7.7 versus, yeah, 8.4 versus, yeah, it does, it reduces it. Not by much. We lose about 7.4 versus Yeah, we lose a volt. So with those capacitors, those secondary ones that I just put back in fitted, we lose a volt above about 13 kilohertz. And I'm not seeing any noise on. Third time. Stop the signal on your phone before you turn the Bluetooth device off. Ugh. So yeah, I'm gonna remove them, and if I do notice any noise coming through when I connect up to some speakers, then I'll fit some better suited capacitors. But yeah, I don't really want a fixed low pass filter. Right, cool. Let's get rid of the solder bridge we made on the power jumper down here, so we can actually switch it off when we want to. And that is now all good to go, all fixed. I will try and quickly show you guys how it sounds. Not that you'll be able to tell anything through this microphone here, but at least you could see if there's any noise on it or something. I guess that might be interesting to some of you guys. Try and quickly get an amplifier hooked up. Damn it. Solder wick to the rescue. Oh no! I just freaking desoldered it! Get back in there, you bastard! Yeah, it's not polarity sensitive, fortunately, it's just along the positive line, so that's fine. Okay, there we go. There we go, there we go, there we go. Okay, let's drop that back in there, get the screws done up. And now the front piece. Typo, what did I miss? Typo, so yeah, we found the source of both of the low pass filters. And yeah, it was another one of those capacitor to ground circuits that was nearer to the output terminals. So yeah. pretty interesting stuff. I have removed, so I've removed now a total of 3 capacitor to ground situations. All 3 of them contributed to the horrendous high frequency response. And as you said, like you very well said, it wouldn't be there if it wasn't necessary. So what I'm going to do is I'm going to listen to it and see if there's any noise as a result of those being removed. If there is, then I will put a much more suitable capacitor values in place, which will filter the noise but not filter the audio signal. But if there's not any audible noise, then I'm just going to send it. That's called an RC low pass, not a cap to ground thing. You can tell that I didn't go to electronics school and I just learned all this by trial and error. Cap to ground thing. An RC low pass. Yes, that was an RC low pass. Should we try and guess what the RC stands for before Typo says what it stands for? RC. Not residual current. Some kind of RC. RC. I can't think of what it could stand for, you know? RC. All I've got is residual current stuck in my head. I can't think of anything else. Control? Oh, resistor capacitor. It was much more simple than I was trying to make it be. Right, okay, so let's plug it in, turn it on, and I'll very quickly connect a amplifier and some speakers so you can so we can just hear what it sounds like, I guess. Just bear with me, I shall go and grab some speakers real quick, some old Rotels. Right, here is some speakers. So now I just need to grab a jack to RCA cable. So I'll be back in a second once I've got that. Here you go, just bear with me a sec. Okay. And I need an amplifier. Let's grab this JL Audio that I repaired yesterday. There we go. JL Audio 5 channel. Nice socks. Yeah, they're odd socks. Because I have a tendency to put holes in my socks really quickly for some reason. Very annoying. Okay, power and ground. And remote. And speaker wires. Let's grab a couple of wires from this one here. This is a Linus screwdriver, yes. I didn't purchase it myself. It was donated to me. It was sent to me by some very kind supporter, very kind viewer of the channel. Decided he wanted to buy me the LTT screwdriver. So here we have it. He sent it all the way over from the States. Try and clear a little bit of space on here. Push this back a bit. There we go. Okay, cool. So speakers hooked up, now I just need the RCA to jack cable going into the front inputs, front section input. Here we go. And let's get the gain turned down to start with. Turn the gain down a bit. Okay, so nope, I'll connect back up to Bluetooth. Remember, Bluetooth doesn't sound great at all. but we're going to connect up to Bluetooth anyway because the internet radio will probably get us demonetized. And go to SoundCloud, I think it's probably best, or maybe, yeah, probably SoundCloud, or maybe Epidemic Sound. Yeah, Epidemic sounds good. Search genres, let's go electronic and dance. No, that's not what I mean. Screw it, whatever. Where's that? Let's try this track. Okay, here we go. So we're running through Bluetooth at the moment, and let's turn the volume down a bit, just in case it's like super loud through this JL Audio to start with. Turn the power supply on, 12 volts, and yeah, I guess we'll go ahead and see if we get any sound. See what it sounds like. Oh, duh. Stupid ass. It would help if I actually plugged the jack in, wouldn't it? Jesus. You can tell that I'm keen to get away from the stream. I'm about to go and have dinner actually, so. Right, let's try that again. It is loud. I think the the volume control only affects the headphone jack. Yeah. There we go. That should be better. Got quite a bit of noise there though. Maybe I can just turn the volume down on Bluetooth. There, I'll turn the volume down a bit on Bluetooth. There we go. Nice. There is quite a bit of 50 Hertz noise actually. Can you hear that? Oh. So if I go up to the speaker here. Yeah, there's quite a bit of 50 Hertz kind of noise, like, you know, like as if you got the jack disconnected. So I wonder whether that is as a result of removing the capacitors, or whether that is whether that's something to do with running it off a car amplifier here, like we are. I'll try disconnecting the audio jack and see if that noise goes away. But either way, sounds good. Yeah, so it actually has high frequency response now that it was completely missing before. So yeah, let's just remove the audio jack and see whether that buzzing goes away. If it does, then it just means it was something to do with, you know, being connected to the car amp and the signal side ground being different to the output side ground. So, oh wait, no, hang on. Yeah, sorry. The buzzing, we need to check if it comes out of this. So I need to plug some headphones in, maybe? Yeah, I'll plug some headphones in. Right. I don't have any headphones up here though. So I will need to plug some headphones in to check whether the buzzing is just as a result of it being plugged into a car amp like this on this setup, or whether it is actually as a result of removing those capacitors and now noise is coming through. Yeah. Do I go and get headphones? I think 50 Hertz is just going to be a ground issue. It's not going to be like, noise coming through this, is it? No, they can't. No, it wouldn't be. It wouldn't be. It wouldn't be. Even if it was, those capacitors wouldn't filter 50 hertz anyway, because it's in the audio range. So that's not the issue. So it's just a grounding loop issue with running it on a car amp in the workshop like this. So that's fine. This is fixed. The issue, the manufacturing defect, has been resolved. Didn't notice any high frequency noise coming through this apart from the from the setup. So I would say that's good to go, and I'm freaking stoked. I'm really, really happy, because otherwise this was literally just going to be e-waste. It was going to be rubbish. We're going to throw it away. And the other one that we've got, this identical, because it just sounded awful. So I'm really, really glad that I was able to take it apart, do a little bit of digging with you guys, have an enjoyable live stream, and at the end of the day, I've now got 2 internet radio streamers that sound acceptable. You know, for my parents to listen to. They're not going to care whether it's extremely super high res or not, but they would care, they do care, and I cared, that it had a massive drop off above like 1 kilohertz, like ridiculous drop off above 1 kilohertz, to the point where there was no high end whatsoever. So I'm glad that we fixed it, and it's actually usable now. Yeah, awesome. This is quite an old design now, so I doubt they care. But either way, guys, it was fantastic to stream with you again. Happy Sunday. Hope you had a good day. I will see you in the next Boom or Bust episode, or maybe on a live stream next week. So I hope you have a great rest of the day, rest of the Sunday, and I'll catch you next week at some point for some amplifier repairs or some Boom or Bust.